If you feel like artificial intelligence has suddenly appeared everywhere, you aren't alone. Over the past year, AI has changed the world, potentially upending every industry and changing how we interact with technology forever. But how does it actually work? In this video, we are going to take you from knowing absolutely nothing to having a solid foundation of large language models, or LLMs. We'll cover what they are, the history behind them, how they are trained, and the ethical challenges we face. So, what is an LLM? Simply put, it is a type of neural network trained on massive amounts of text data. We're talking about data scraped from the entire internet. Books, transcripts, websites, anything text-based. Have you ever been texting on your phone and you type, "I am going to the," and your phone suggests the word store or park? That is basically all artificial intelligence is. It's just a really good guesser. We call them large language models, or LLMs. But today I'm going to skip the boring math and explain exactly how they work using a parrot, a library, and a game of fill in the blank. Imagine you wanted to teach a robot how to speak. You wouldn't teach it grammar rules like nouns or verbs. That's too hard. Instead, you just force it to read everything. And I mean everything. Every book in the library, every article on Wikipedia, every Reddit comment, and even every recipe for chocolate chip cookies ever written. This is the large part of large language model. It has read more text than a human could read in 1,000,000 lifetimes. Now, while it was reading, it wasn't understanding the meaning of love or heartbreak. It was just looking for patterns. It noticed that the cat sat on the is usually followed by mat, but sometimes it's followed by chair, and almost never followed by toaster. It assigns a mathematical score to how likely words are to appear next to each other. These scores are called parameters. Think of the model as a machine with billions of tiny knobs. When it reads "the sky is," it turns the knobs until the word blue lights up. GPT-4 has nearly 2 trillion of these knobs. That's why it's so good at guessing. So when you ask ChatGPT a question, it's not actually thinking like you do. It's acting like a super smart parrot. It looks at your question and asks itself, based on everything I've ever read, what word usually comes next? To understand LLMs, you have to understand how they differ from the software we've used for decades. Traditional programming is instruction-based. It follows the logic. If X happens, do Y. You have to explicitly tell the computer exactly what to do. But with AI, we aren't teaching the computer how to do a task. We are teaching it how to learn to do the task. Think about image recognition. In traditional coding, identifying a handwritten letter A is a nightmare because everyone writes differently. You'd have to write a code rule for every single variation. But with AI, you just give the computer a bunch of examples of what an A looks like, and it infers the pattern. This makes LLMs incredibly flexible and scalable compared to old-school code. The history here is fascinating. It goes back to 1966 with a model called ELIZA. It was the first language model, but it was very limited. It just used pre-programmed answers based on keywords. Things moved slowly until a massive turning point in 2017. The Google DeepMind team released a research paper called "Attention is All You Need." This introduced the transformer architecture. The transformer was revolutionary. It allowed for faster training and a better understanding of context. This led to OpenAI releasing GPT-1 in 2018, and eventually the famous GPT-3 in 2020, which had 175 billion parameters. This paved the way for ChatGPT 3.5 and the massive GPT-4 released in 2023, which reportedly has a whopping 1.76 trillion parameters. Okay, let's get technical, but keep it simple. How does the model actually read? It happens in 3 main steps. Step 1 is tokenization. The model doesn't read whole sentences like we do. It splits text into chunks called tokens. A token is about 3/4 of a word. Simple words like that might be 1 token, but a complex word like summarization is split into multiple pieces. Step 2 is embeddings. The model turns these tokens into lists of numbers called vectors. This allows the computer to map out relationships between words in a 3D space. Imagine a 3D map. Words that are related appear close together. For example, book and worm might seem unrelated, but because they often appear together as bookworm, their numbers, vectors, will be close to each other in the database. Step 3 is the transformer. Using an algorithm called multi-head attention, the model calculates how much each word contributes to the meaning of the sentence. It predicts the next word in a sequence, based on all the context it has learned. Training these models is incredibly expensive. We are talking about massive amounts of electricity and expensive hardware from companies like Nvidia. The process follows the rule of garbage in, garbage out. If the data set is biased or incomplete, the model will be too. During training, the model tries to predict the next word millions of times, adjusting its internal weights until it gets it right. We also use reinforcement learning from human feedback, RLHF, where humans grade the AI's answers to help it improve. But here's the cool part for developers: fine-tuning. You don't always have to build a model from scratch. You can take a general model, like GPT-4, and teach it a specific job. For example, if you want an AI to take pizza orders, you feed it transcripts of customers ordering pizza. The model updates its understanding to learn pizza terminology and customer service tone. It becomes a pizza expert. AI isn't perfect. One major issue is hallucinations. The model can confidently state something that is completely wrong. For example, if you ask an LLM to count the letters in a specific string of text, it might confidently give you the wrong number. They also struggle with math and logic compared to humans. There are also ethical issues. Since models are trained on internet data, they can inherit human biases. There are ongoing lawsuits regarding copyright because these models digest books and articles without asking the authors. And of course, bad actors can use them for scams and misinformation. So what's next? We are moving toward mixture of experts models, where multiple specialized models work together to answer your question. We are also seeing retrieval augmented generation, RAD, which lets the AI look up new data that wasn't in its original training set. The white-collar workforce, lawyers, writers, coders, is going to be disrupted. But remember, AI is the worst it will ever be right now. It's only going to get better. Thanks for watching. If you want to learn more, check the links below, and don't forget to subscribe. Thank you for watching. Please subscribe to our channel.